Hi everyone. So today's notes are going to be really quick because what we are learning is what is called the ideal gas law, which the equation for that is listed up here at the top. It's PV equals nRT. Now there are some specific requirements to use this equation. So sometimes where this is one of those instances where the units that are listed here are the units it has to be in. So there's no exceptions. It's not like our other gas laws where we have some options to use. It has to be these units. So pressure has to be in atmospheres, no other options. Volume has to be in liters. N, which is this lowercase here, is going to be the number of moles that you're looking at, so moles of gas. R is a constant, so this is what's known as the universal gas constant. This number will always be given to you. And then the temperature has to be in Kelvin, which we've seen before. So literally for this set of notes, we're just doing some practice problems and moving on. So when you're trying to do an ideal gas law problem, go through and identify your variables first, then decide if you have to do any unit conversions. So the question, determine the pressure exerted by 2.25 moles of oxygen in a 7,500 milliliter tank at 35 degrees Celsius. So we are determining the pressure, that's our unknown. Our volume is 7,500 milliliters. Our number of moles is 2.25. It's given to me right there in the problem. And then the temperature, 35 degrees Celsius. So I need to convert milliliters to liters. So this becomes 7.5 liters. If you don't know that unit conversion, you might want to refresh that. And then turning Celsius into Kelvin, you add 273. This becomes 308 Kelvin. So now we're ready to plug in. PV equals nRT. Pressure is our unknown variable. Volume is 7.5 liters. Moles are 2.25. R is 0.0821. And the temperature is 308 Kelvin. So you literally just go through, multiply what can be multiplied, divide out that 7.5 that's beside the P. You find that pressure is equal to 7.6 atmospheres with correct significant figures. So it's really that simple. You just have to plug the numbers in and use algebra to solve for your unknown variable. Let's try another one just to say we got some extra practice in. So a tank for a grill has a volume of 5 liters. On a day when the temperature is 28 degrees Celsius, the propane gas in the tank exerts a pressure of 8.85 atmospheres. Calculate the mass of the propane in the tank. So we read through our problem. We see that we have a pressure of 8.85 atmospheres. We have a volume of 5.00 liters. We have, we don't know the number of moles, doesn't tell us that, so that's unsure. And our temperature is 28 degrees Celsius. So what I'm gonna do is I'm going to be finding the moles of the propane, and then I'm going to convert that into mass because, oh wait, that's not 18, it's 8, sorry. We can't directly solve for mass in the ideal gas law, but we can solve for moles, and moles can be converted into mass. So that's what we're going to do. But before we do that, we want to change this Celsius into Kelvin. This becomes 301 Kelvin. So PV equals nRT. We're going to plug in our numbers. Pressure is 8.85 atmospheres. The volume is 5.00 liters. N is our unknown variable. R is 0.0821. T is 301 Kelvin. So we multiply the stuff on the left. We get 44.25 equals N times 0.0821 times 301. We divide out the stuff on the right to isolate N by itself. We find that N is 1.79 moles of propane. Now what I want to do is convert that into mass of propane. So I'm going to take 1.75 moles and I'm going to convert it to mass using the molar mass. So I'm going to add up the three carbons, the 8 hydrogens. That adds up to 44 grams, 78.8 grams of propane is what's in that tank. Okay, so this extra step that we did there at the end was just because we were being asked to solve for mass. So that's why we had to do that last step. And that's how you do ideal gas law. Simple as that.